9.3, dominance matrices. Now I know 9.3 starts with communication matrices, so I'm going to do a little bit of a recap on that, but seeing as I've already got a video that gives you the examples from last year, I'm not going to just repeat myself. Touch of a recap. So we're talking about a communication matrix. So what is a communication matrix? It's a matrix that indicates how to get from A to B or A to C. In this case, we've got our diagram on the left-hand side. We've got an arrow coming out of point A through to point D, and we've got a double-ended arrow going from point A to C. So what does all this mean? It means that we can get from point A to D directly. So if I'm going to create myself a matrix, so we can go from one to the other, I'm going to put A, B across here, C, D. So it means I get from, this is my from, and my A, B, C, D, and I get 2. So we're talking, say for example, in this example that they set up, talking about airports, getting from, what have they called these guys? Arcton to Dunton, A to D. So because I can get from A to D, I put A1. I can get from A to D. Now I can't get from A to B, I can't get from A to A, and I can't get from A to B, so I put zeros on both of those. Now I have a double-ended line, or a double arrowed line, so it means I can get from A to C, and I can also get from C to A. Now filling in all of this matrix, all this matrices, I end up with, I'm just going to run through it all quickly. 0, 1, 1. I cheated and did it before. So what all this means is that I can get from, I'm going to change colours and show you a few things. I can get from A to D here, and that's my pink line, which is now green. I can get from A to C there. Then changing colour, we'll go orange. B, I can't get from B to A, which is why I've got a 0. I can't get from B to B. I can get from B to C, and I can't get from B to D because it's the arrow travels in the wrong direction just up here. This is called a one-step communication. So that means taking one step to get from A to B. Now the second example I'm going to run through is a two-step communication. So that means I can get from airport A to airport B, but I have to go via a stopover. So I can get from A to D to B, or I can get from A to C to B. So when I'm creating my matrices, or my matrix, I always pluralize and singular when I shouldn't. What it means is that I can get from A to B in 2 ways. So I can't get from A to A, but I can get from A to B in 2 steps. If you look at the first matrix and you go, what the heck, why am I supposed to figure this out? I'm going to just confuse the heck out of myself. You can take the easy way out. And all you have to do is enter it into the CAS, use CAS. And find, if this is called matrix M, find M squared, which again I did earlier on the calculator. And I end up with, let me get rid of that. I can actually get from A to A. I can go A to C to A, but I don't need to go into detail. So this is what the CAS has told me, that I can get from A to B in 2 ways by taking sort of a detour airport. All right, so that's enough on communication matrices. Go back to look at my other video and it'll run through it all with you. So what we're talking about now is dominance matrices. Dominance situations are similar to communication situations, except all the arrows in a dominance diagram are one way. So before we had the little two-way arrow there, in a dominance diagram, we don't have those. We just get from A to B or A to C and we don't go back again. So examples of dominance situations involve competitions where there are winners and losers and food chains where animals eat each other. So if you're thinking a soccer game. Australia plays Italy, Australia wins. Italy doesn't. Therefore, the arrow goes from Australia beating Italy. Slim chance of that happening, but hey, you never know. Or food chains where animals eat each other. So, for example, we've got our plankton. The arrow means is eaten by a small fish, which is eaten by the shark. Whereas, and there could be something off the other side, the shark also eats, say the shark, shark also eats the dolphin. Don't think it happens like that, don't know. So that's how a dominance matrix or a dominance diagram works. It's all one way. So our first and actually only example is a basketball game. So Abby, Bess, Kath and Denise play off against each other in a series of one-on-one basketball games. In these games, Abby beats Bess. Bess has no wins. Kath beats Bess and Denise beats Abby and Bess. I should change the names. Too many S's, too much tongue tying. So first of all I'm going to do is I'm going to label these girls. We're going to go Abby is an A, Bess is a B, Kath is a C, and Denise is a D. Complete the dominance diagram to indicate who defeated whom. So we're going to put our A, B, C, D, like our airports before. Now, Abby beat Bess, so I draw a line towards Bess and I put my arrow. Bess had no wins, so nothing comes out of B. Kath beat Bess and Denise. And then Denise beat Abby and Bess. That looks about right, I think. I'm going to assume that's right. Yeah, it looks about right according to the picture I've already drawn. Okay, now find M, the dominance matrix. So it's using the same step that we had with the communication matrices, where we put our A, B, C, D, and our A, B, C, D on the other side. Draw my square brackets. Now, these are the winners. And these guys are the losers. Well, not really losers, but the people that lost. So A beat B. So A didn't play A, but A beat B. A didn't beat C, and A didn't beat D. Going through B, she won nothing. C, she didn't beat A, but she beat B. She didn't play herself, and she beat D. And then the last one we're looking at, oops, bugger. My hand's too heavy, is Denise beat Abby, Denise beat Bess, she didn't beat Kath, and she didn't play against herself. And this is called M. Should put the M at the start, but this is called M, my dominance matrix. So it's using exactly the same steps we took in the communication matrix, except that all of these arrows are only one way. So that's part A and B completed. Part C, find how many wins each person had. So what I'm going to do is I'm just going to pop down my matrix again. My matrix M is equal to A, B, C, D. And it was Bess had no wins, Kath had a couple, and Denise had a couple. All right, now the easiest way to do this is to look at the winners and add them up downwards. Oops, that colour's not going to be bright enough. Let's go yellow. So what I do is I look down the column. So I could multiply it by a row summing matrix. If I really wanted, which would look something like this, 1, 1, 1, 1. And then I would add the columns, because you know the rule is when you're using a row summing matrix, you add the columns. When using a column summing matrix, you add the rows. So I would add the rows here, and I would end up with 1, 0, 2, and 2. That just means that Abby had 1 win, Bess had no wins, Kath had 2 wins, and Denise had 2 wins. So that's part C covered. Now, just below this, you can see a sort of a CAS screenshot. The next step is you're doing matrix multiplication. If you don't have to do this by hand, don't do it by hand. Do it by CAS. So what I do is I put my matrix into the calculator and I label it M. As you can see, I've used the control stow, which is that little variable arrow guy button. So that means store. So I'm storing M as that matrix. Now part D says find M squared and explain what information this matrix gives us. And as I said, it's easier with a CAS. So I typed in M squared because I already had my matrix stored as M. I did M to the power of 2 and I ended up with my 2-step dominance matrix. This is a 2-step dominance matrix. So what M squared tells us is how often a player defeated a player who had defeated another player. It gives us the number of indirect wins. So even though, so I'm going to put A, B, C, D along the bottom here. So even though Kathy didn't, and A, B, C, D across here, even though Kathy didn't play Abby, so this is Kathy here, and that's Abby there. Even though Kath and Abby didn't play each other, we can see that Kath defeated a player who defeated Abby. So how this works is that Kath defeated Denise, who defeated Abby. Therefore, it's an indirect win. So we can also see here with B that Kath defeated a player who defeated Bess, which was also Denise. And Denise defeated a player who defeated Bess. You can see in column D. So that means that Denise beat Abby, who beat Bess, because Bess won nothing. All right, part E. Getting ahead of myself or falling behind, whichever. Find the M plus M squared and explain how this could be used to work out who won the playoff. So remembering that M is our direct wins. So for example, I'm going to put some examples here. Who did Kathy beat? Kath beat Bess. And then put an arrow right over here. M squared are our indirect wins. So we're saying that Kath beat Denise, who beat Bess, and Kath beat Denise, who beat Abby. And then what we've done is we've just added them together. So although Kath and Denise both had 2 direct wins, summing the columns M plus M squared, so let's add them downwards. So we've got 1, 0, 4, and 3. Tells us that Kath had a total of 4 direct and indirect wins. Denise had 3 direct and indirect wins. Based on this, Kathy has dominance and should be declared the winner. So this is Kathy here. Column C. So we do M plus M squared, and that'll tell you in that column who should be the winner.